part of the risk management, securing the necessary resources and supply chain through targeted development of electronics. In English, I guess.
We do it in English, yes.
Okay.
Okay.
Stage is yours.
So, thank you very much for your nice introduction. I will go a little bit forward and lead you a little bit through the program or the lecture we do. So the first is very short, what we do and what we do, who we are. The next is the requirements necessary to operate in regulated markets, to give an overview about all the quality management systems and the thing you should take into consideration if you want to enter in a market like the aerospace and defense. Then are bringing on an example from the medical, showing a little bit deeper in the production. Reason for using medical is there is not so much non-disclosure behind as in the other field, but if you have a little bit of imagination, you will see that you could use it in different kind of applications as well, and I show some of the ideas we may have for that. So then we go to within this application to the initial situation and what challenges we were faced with in the beginning. So we have different challenges. The one is how to design and develop such a tool which will be implemented in the body of a person and send signals out of the body. And the major point is you should have, or you should think about of all the materials we have chosen for such a material, for such a device. And on the other hand, how can we secure the function of the system and to bring it up to a serial production for a long-lasting period. So therefore, the technical implementation, then we show, or I will show another promising technological approach we use today for such kind of things, because the other one is still in the market. And then the big question, what role did risk management and the obsolescence play in these example I will going to show? That means what are all the things we have taken into consideration, what we have to mention about such a project, and what does that mean to risk management, the supply chain my colleague just mentioned on the speech before. Well, as promised, I go a little bit further. So we are segmented in 3 divisions. So the company is next year, or celebrates next year, its 60th anniversary from the foundation. And we have 3 fields. The one is high-tech industry, as we called it. And therefore, you see all the production sites and the engineering sites. We are serving technology-intensive sectors and industries with our products, with the developments and the manufacturing. If there are some question about the company, you can afterwards easily ask me, not to bore you a little bit with all this. The second major thing is the medical, pharmaceutical, biotechnical, and means what we're doing there is we starting from the idea up to the ready product for a lot of our customers in the different fields. And there are a few part of pictures you're seeing where we are in is coming from the fields of implants, as the same as we will have a look on this example. The other ones is an ocular implant in the eye. You see an older respiratory device. The reason of this is the picture rights, in that case hearing aids and so on. And the other ones to show you, we of course also nearly 30% in the field of aerospace and defense. We are serving more than 30 leading implementation system houses, in that case, or OEM as the car industry maybe call it, from the big ones. And that means we also starting from the development design stage up to the manufacturing into the production, and be very sure some of these products lasting more than a few decades. And all this plays on land, on sea, on air. I have nearly forgotten it, and beyond. I will show on beyond a sample as well. You see where we are in the world. I hope there will some other places join us in the next few months, and I'm very sure about that. Okay, then of course, final picture, ESG makes the difference even in the aerospace and defense sector for a good working company and those companies which may be not really on the competition line or on the line you should be. So let us see a little bit in the requirements which are necessary if you want to operate or go into the regulated markets. And what you see is, thank you to BAE, it's the FCAS Tempest, is one of the FCAS models. The Europeans, as you may know, will have two, the one of the French, German. We will see what happens with these guys, and the Spanish, and the other ones are the British and the Italians, which are here in these interesting. So that gives you a short overview what kind of quality management systems you should be aware of, which you take into consideration or you should mention about. That means very often you will see here the EN 9100. It's for the aerospace and defense, especially also on the aerospace, if that is the civil version, the multi-use or the military ones. You will have the 27001, which means is a full part of data security, security in general, and all the security processes you have to implement in your company. So to give you a few examples, it will be encrypted communication system, restricted areas for your data storage, maybe a server or server systems in the country where you want to do your business. It depends a little bit on the security system and what kind of security levels your personnel or the product or services you sell may have. Also, it's the very new ones now from the European Union. It's the NIS2, which is the Cyber Security Act. And with the Cyber Security Act, in combination with the 27001, you will have mentioned an own security system as a part of the risk management in your company to fulfill all the requirements to do business in this section of the aerospace defense, as well in the medical or in the pharmaceutical, or maybe you have some technological difficult places. So, and then there are a lot of other things. I will only give a little bit an idea of that, what you all have to read, because there's a lot to read after that. If you want to go in these fields, it's the AQAP, it's the Allied Quality Assurance publication. It's more or less a NATO quality standard you have to fulfill if you want to serve. It's the JOSCA, Joint Supply Chain Accreditation Register. And in this one, you see it's more or less an European standard. You will see it very often also in the UK. The other one is NatCap. It's, in that case, a global, more or less global standard for these aerospace and defense buying programs. Well, these military standards or NATO standards or whatsoever will ever apply when the civil standards are not enough or not cover enough in that fields. And it depends a little bit on the countries, on your system integration companies, what they are like, where they're doing a business, where their products may go, and to what of consumers say serve. But you should be very aware there's only, for each country, there's only one customer. It's the state and nobody else. Maybe in the US you have 3 customers, then it's the naval, the air force, and the land power. The other ones is, maybe if you're looking a little bit more in the European one, you see EDSTAR, you see the European Defence Agency. It's a little bit that the Europeans try to keep all the countries together and make a common standard for all. We will see what happens there. But in general, what is important, if you're sitting in Germany, it's the Federal Office for Equipment, Information Technology and Use of the German Armed Forces. It's a difficult word. It's BAAINBW. So not easy to speak in that case. And if you have non-electronics, if you have maybe metal or mainly metal or metal where electronics will be placed in, you should be VG listed to serve the German armed forces. Otherwise, you have to wait nearly, I think it's 9 months or up to 10 months, the time until you get the certification if you're doing everything right. Well, so that is what I mentioned before, is there's still one customer, it's the state, and therefore every state has some special requirements, special, I would say, resources he want to be placed in his country. That means someone of you maybe know the word offset. It's just in some, if when your system integrator or the seller of an entire system is selling that to a country, the country likes to have the major part of the production on his own ground. And that means if you want to do business with them, you should take that into your consideration, that in some places you provide from such a system, and on the other hand, you maybe suffer a little bit from the system because that one of your products you could sell in this direction then will be placed by your competition or whatsoever else. The other thing is your personal stuff, and it depends also how deep you go in the products or the services. That means in some cases it's only allowed that one person with a special security conformity accreditation is allowed to get or to look in the data. And there are typically 9 levels in that case. And if you really have, for instance, software, if the software is Frank-Ralf, or if the software is going into maybe the readiness of products, as we do maybe in UK, that we're sending out the U-boat or the sub, and the sub is then ready for combat. And if you're doing that, your people which are allowed to work on that must be in these levels. And if then the general manager maybe has not the levels, he cannot control his own employees in the case, maybe for a funny situation. So in German, that means I have wrote extra the word, and the shortage is SUG, Sicherheitsüberprüfungsgesetz. That means if you're not speaking Germany, forget it. Read the other part because it's much more easier. So maybe a new part, if you're not in the business, is the typically or atypical small amounts and quantities you need for the products. And that came from, if you think at a tank, how much tanks Germany has, I think 270, something like that. The other states a little bit more. So we're talking about 200 systems, 200 parts of electronics, even if there are 2, 3, or 4 parts of the same installed in the system. It's not that much. If you maybe think about automotive or different kind of sectors where another figures are in the place. So, and if you're now going to a typically electronic parts distributor or manufacturer and ask him you want 100 parts or 200, however you be called, however what kind of names you carry, it plays no role. So, because then you are really a really small customer in such kind of field. Well, let us go in the sample, and as I told, I'm using the medical as a good example because it's not in a security level in that case, and it's an existing product to show you, but it's was a long way to reach this product, and that this product is now in the serial production. And the reason is it's not so far away because the medical system is also a very regulated market, the same as the aerospace defense is, or the pharmaceutical, or the biotechnology. So one thing is, it's now a very nice picture shows you a little bit. Normally good blood flow is essential for your life, for your wellness being, and that all your functions in the body are working in that direction you like or what is necessary. And if that not happens normally in the parts where the blood flow, you will get a stent, and then the stent opens again and more blood can flow through. But the problem is that nearly in 3 up to 10% after these surgeries. So the stent is grown and closing again. And the reason for that is known, the illness called restenosis, and that part. And the interesting thing is, in that time when we was going with our customer in the mutual design stage and development stage, there was no other devices on the market to do all-time monitoring of the patient. So what you see is there was some tests before to measure the bloodstream, and one of them is you can look optically in the system and measure it and to the blood vessels, or you do it with an ultrasound system in that case and measure it also. The problem is that the patients have in this moment sitting on your chair, if you are a doctor in that case, and then you measure or monitor the status. But the problem is at the next day, the status can differ to the situation in the picture that he gave yesterday. Okay, so the situation, as I told, was no existing solution, long intervals between examinations, if you're going to the doctor, late detection of restenosis, and normally need of a pre-warning system. Well, and therefore the decision was there is no device on the market, so we go into the market, and then we have to take in consideration that we want to sell, or firstly to let the device work nearly decades because it's in your body, and the other one is to support the realization that the product can go in a serial production and run with the same things, with the same products, with the same materials. And now we have to maybe in mind, if that is a regulated market, we have to think about years or decades to realize that. So the first idea is the product should meet all requirements, and it's quite similar in all regulated markets. So the product should be durable and in the long term consist of individual parts and materials that can procured again on the market. And you think on PFAS and different kind of things. You have also in mind what will be happened in the European Union. In the decision, California or different kind of states which have a restrictive governmental system for such markets, then the process should be easily documented, and it should be made clear that everything is traceable, is futurable, procurable, and that you get the approval in accordance to all the regulated requirements from the market. Well, how we did the technical implementation, and you see that is a part which describes it like a scheme inside and outside of the body. We use it by a resonance circuit configuration, and we send it wireless a signal, which is a different one from the starting up to the end, to an outside readout. Well, the picture is looking like that. That's now the original from that time. It still is in the production, and it's still in the sales in the markets because it got the approval in different kind of markets, especially in the US. And actually there is a readout with the mobile phone of the system so that you get informed by your status of the monitoring of your blood flow internally of the body. And now we see how you can solve that differently at the moment. And this one I've provided a fully embedded system. That means these fully embedded system, and that phase with an ASIC die internally will be implanted in your body and give the signal out, even if that is only a scheme and not an exact drawing to tell too much. And to show you how that could look like, these are approaches without using any single electronic part. It's totally printed. That is maybe the new thing around. And therefore now we're coming from the medical a little bit to, I would say, security approaches to show you what you can do with this. So I wrote it's a strain sensor, an ASIC printed, and you see the real material. That means from the production, you shouldn't forget that what I have mentioned before, that you of course have to think in the material. And you, of course you have to think in the inks you're using, and the materials, and the silver, in all the products inside of the things, and of the ASIC, which is in that case completely embedded. Well, we have produced things, and what is maybe very interesting is the chemical sensor array is still an existing product. So what will be done? It will measure it if you are using drugs. It's now from the American harbor authorities used. That means from the customs, as you come in, normally you spy a little bit on a spattle or something, and then it will detect it, and it needs a little bit on a biochemical basis. This one is a fully digital electronic thing, and you can document it at once. You get at once the signal what kind of drugs you have used, and if you maybe, or I could say Maya is now seen by the police the third time, so you have to go to prison or something in that case. The other one is, of course, the chemical warfare agent. All right. From the technological standpoint, it's not too much difference. So, if you have some imaginations about, you have to use different points, maybe a different kind of measurement behind, but you can produce it in the same way with a different application. The other one is a wireless contact system. It could be used for an automatic detection and assignment. Think if your comrade will come on the war field to you and have a weapon, and normally we'd say, okay, he looks like me. I do not know him, but he looks like me. But maybe the weapon automatically give the okay or not okay. And so an automatic friend-first system in the glove, in the boots, whatsoever. And the other one shows a little bit of the entirely embedded chip and circuits in housing parts, what you can use in buckles and whatsoever else to using something. Think about the AI-controlled warfare or in these fields, and you see that information at the end will differ. So the different kind of parties in such a conflict. So, okay. So what has it to do with the risk management in play? This is a sample. It means you should have a look on the material you use. You must be very sure about how long you can use the material, how long will the material on the market for procurement, and is allowed from the local and international governments. So it means you need a long-term planning system. So we used, in that case, a so-called obsolescence management strategic system and reformed that a little bit because they have a different kind of systems, especially for the project I have shown before. And that will a so-called conceptual system, which we have calculated that must be the right system which fixes on all the question of the project and the challenges we had in the system. The other one, the very most people forget in such a thing, as you may can imagine, is we need a hell of people working on different kind of fields, in the planning, in the design, in development, not to forget the procurement, the strategic procurement and all the things, and of course the financial planning. You should have a proper financial planning. We called it life cycle costs in total, and do not forget, if you were now in the medical or other things, in the aerospace and defense, I don't think that the waste disposal will go on the sheet, but I think in all others as well. Okay, so that means you have to protect your money at the end of the day, and that's now, of course, a part of the risk management against production losses. If the material is wrong, if the material get no approval, if maybe the parts are now only in a single source, or you lost a single source, or quite similar, and that means there are different kind of things how to calculate these things. And now it's maybe a very fine thing the very most people forget. All these things which are not only material. So due to the increasing complexity, additional technical, human and financial resources will need it. And the interesting thing is now from the university, what you see, it's a calculated time. If you're thinking, if you're not had a good planning, you will be faced that the additional needed resources in design development will be double as calculated than if you're looking on the financial and human resources of that, it will be 3 times more. And the intangible assets, as it's called not in the balance sheet, it's more than 4 times. So, and if you want to go in these markets, all regulated markets, you follow these points and feel quite much more comfortable if you forget that. And even your boss and the financial also. And you see where all these plannings were going in now in a product which is which I called Beyond. It's driving on the Mars fully automatically, and all the electronic is in. Now you can imagine what it means. It will last years or 10, because if these electronic fail, the system fails entirely. And I'm not sure if you can use a normal public rocket to visit the Mars and do all the maintenance. Well, the other ones is give you only an overview for system which were designed and manufactured with all the same risk management and obsolescence systems. It shows not too much. In that case, it's hermetic sealed systems. It's also must be very controlled. It's for the avionics system. It's secure networks, satellite networks for naval bases, and something in that case. It's ground systems. It means it's detection. Actually now in systems like AI controlled, it gives you an answer. You see here the desk where you get the answer which weapons or systems to get into your new approach, or to get an idea what you can use and what to set for a counter message in the system. Okay, so I hope I'm not too fast.
Everything good?
Wonderful.
Just in time. Do we have questions from the audience? Doesn't look like we have questions from the audience. That means you have already told everything.
Yeah, that's fine. Wonderful. So thank you very much.
I guess.
And if there are any questions later on, you can ask me.
Yeah, you can meet him at the booth, or he's here for a couple of minutes. And yeah, thank you very much.
Thank you.